Domain is the set of number inputs for which an expression is defined and there is a real number output. For example, take 4 divided by x. X can be any real number, but we don't want x to be 0 because then we'd have division by 0, which is undefined. So this rational expression is defined for all real numbers. For example, if x is 2, then 4 divided by x, when x is 2, is defined or has an output of 2. But 4 divided by x is undefined for x equals 0, because if we input 0 for x, then we have an expression that is undefined, since division by 0 is undefined. And we use U and D for undefined. Number 1, determine which of the following numbers are in the domain of the variable. So generally, the working set is the set of all real numbers. So this rational expression is defined for all real numbers except a number which would make division by 0 or the denominator equal to 0. So by inspection, we can see and say that if x is negative 4, the denominator would be 0. In more complicated cases, we would set the denominator equal to 0 and then solve. The solution of negative 4 is the number input, which would give division by 0. So this rational expression is defined for all real numbers except negative 4. So the domain, let's use D for domain, is the set of all real numbers except negative 4. And to express except negative 4, we can use what looks like a minus, but it's interpreted as except any number or numbers in this set. And the only exclusion or restriction is negative 4. So all real numbers except negative 4. X plus 8 divided by x squared plus 3x minus 40 is a rational expression defined for all reals except any value of the variable, which would make the denominator equal to 0. So what we'll do is set the denominator equal to 0. In this case, we have a second degree trinomial or quadratic equation, and we'll solve for x by factoring. In factoring, the first step is always to look for the greatest common factor, which in this case is 1. And because it's a second degree trinomial, we'll try to factor it as the product of two binomials, first term x. And then think of a pair of integer factors of 40, which will add or subtract to give 3. In this case, that would be 5 times 8. And to be able to FOIL and get plus 3x as the middle term, we'll need a plus 8x outer product and minus 5x inner product. And these constants multiply to give minus 40. So this checks out. So now by inspection, we can see that if x is 5, then the denominator will be 0, or if x is negative 8, we'll have division by 0. So we want to exclude 5 and exclude negative 8 from the domain of all real numbers. So the domain D is the set of all reals except for these restricted values of negative 8 or positive 5. Rules of exponents. If x is a real number raised to a negative exponent, and it's assumed that n is greater than 0, This is equivalent to 1 divided by x raised to the n. In the next expression to the right, 1 divided by x raised to the negative n, again assuming that n is positive. We can rewrite this as x in the numerator. So it's kind of like saying move the base to the numerator from the denominator, and the exponent changes sign. And now we have n. It's also x to the n divided by 1. In multiplying x raised to the m times x raised to the n, this product is base x raised to the sum of m plus n. X raised to the m, quantity raised to the n, equals base x raised to the product mn, m times n. The quotient of x and y, quantity raised to the n, which would mean to multiply the fraction base repeatedly, would give x raised to the n divided by y raised to the n. Y cannot be 0. Number 2, negative 2/3 quantity raised to the negative 4. Well, the longer way to do this would be to write this as 1 divided by negative 2/3 with the fraction raised to the positive 4, and then proceed from there. Or a shorter method is to invert the original fraction. Let's make that negative 3 divided by positive 2. And then the exponent of negative 4 changes sign, becomes positive 4. Next, we would raise the numerator to the 4th power and raise the denominator to the 4th power. And this will equal positive 81, positive since the exponent is 4 and even, divided by 16. Number 3. We'll multiply the coefficients first. That could be a mental step, 8 times 5. And then we'll group x to the first times x squared, and then add the exponents. Then group y to the third times y to the first, and then there's z cubed. So this equals 40x cubed, y to the 4th, 3 plus 1, z cubed. Number 4. Now notice there's a negative exponent to work with. So in applying the power of a power rule, we'll start with 3 to the 4th power, a to the 4th power, and then b to the 4th, quantity raised to the 4th. Now, one way to get rid of the negative exponent is to rewrite it as a fraction, 1 divided by 6a cubed, b to the 5th. So those exponents remain the same, but the outside exponent becomes its opposite, positive 3. So next we have 3 to the 4th is 81. A to the 4th, b to the 16th times 1 divided by. So we can write the result of cubing in the denominator. So let's write 6 cubed. A cubed cubed. You multiply the exponents. 3 times 3 will give a to the 9th. And then b to the 5th raised to the 3rd. You multiply the exponents. That'll give b to the 15th. Now, without a calculator, let's do this by hand. And since 81 has factors of 3, and in the denominator, 6 cubed has factors of 3, we can go back, change 81 into 3 to the 4th. And then 6 is 2 times 3. Quantity cubed. In dividing a, we can divide and cancel 4 a's in the numerator, cancel 4 a's in the denominator. So we're going to have a to the 5th in the denominator. Then in dividing b to the 16th by b to the 15th, you can either divide and cancel or subtract the exponent. 16 minus 15 will be b to the 1 or just b. All right, so we have 3 to the 4th, which is 81 again. B in the numerator. In the denominator, we have 2 cubed times 3 cubed, a to the 5th. Simplifying, let's put the answer in blue above. We're going to have 3 to the 4th, which is 81. B in the denominator. Let's reverse. And instead of 3 to the 4th is 81, let's think about dividing and canceling 3 to the 4th by 3 to the 3rd. So in other words, you can divide and cancel 3 factors of 3, and that'll leave 3 to the 1st in the numerator. So we're going to have 3 in the numerator. B divided by, in denominator, we have 2 cubed, which is 8, a to the 5th. Final answer. In number 5, we have a negative numerator, negative denominator, and negative divided by negative is positive. And then we have the negative sign on the far left. 64 and 14 are even. We can divide by 2. So half of 64 is 32. Half of 14 is 7. Now in dividing r's, we can apply the subtraction rule for exponents. 8 subtract negative 5, which equals negative 32 sevenths times r, and 8 plus 5 is 13. Number 6, apply the distributive property of multiplication over addition, or it could be over subtraction. Okay, so the first problem is to distribute A times B, or AB, plus A times C. The reverse is to find the greatest common factor, which is A, and then factor out A. In the next expression, we're going to distribute -4. The minus in front of the 5 is subtraction, but we can think of it as a negative. Subtracting 5 is the same as adding -5. And then -2, we can think of that as adding -2 times and distributing. Think of it as a -2 times each term inside of the parentheses, minus 5x squared, or add -5x squared. So it's like a -2 times a -5. So with some mental calculations, we have -8x squared plus 20 minus 6 minus 2x and plus 10x squared. Combining the like terms of greatest degree, the quadratic terms or second degree terms, squared terms, with a little mental algebra, or we can show the step of adding the coefficients of the squared terms. We have a single linear term and then a constant. Final answer is positive 2x squared minus 2x plus 14. Now we had a factor, the trinomial at the end. We look for the greatest common factor and factor out 2. Number 7, is the following expression a polynomial? If it is a polynomial, determine the degree of the polynomial, state the leading coefficient, and whether the polynomial is a binomial or trinomial. In number 7, the exponent -2 on the variable makes this not a polynomial, because a polynomial is a single monomial, or the sum or difference of many monomials, but the monomials have to have whole number exponents and cannot have negative exponents. So because of the -2, this expression is not a polynomial by definition. Number 8. So all the exponents on the variable x are whole numbers, so this expression fits the definition of a polynomial. And if we write the polynomial in decreasing degree order, which is common, and write the 4th degree term followed by the cubed term followed by the squared term. Now let's pause on 2x to the 0. X to the 0 power is equal to 1. So 2 times x to the 0 power is 2 times 1, which equals 2. And there's a constant of 4. So adding 2 plus 4, we'll get 6 when we simplify. So the greatest exponent on x is a 4, so that makes this a 4th degree polynomial. The leading coefficient is the coefficient of the term of greatest degree, which is 4. So -3. Number 10. Simplify this rational expression. We're going to keep the negative sign, the first negative sign on the far left. Now the numerator is the 10th power, which is even, of -10, and therefore the final product after repeated multiplication will be a positive result. So we'll drop the parentheses and the negative sign of the negative on the base -10 and just make that 10 to the 10th divided by, and we can drop parentheses in the denominator, that's 10 to the 5th. simplify further. So we have negative, and by the subtraction rule for exponents, we'll keep the base, subtract the exponents, and this is the same as a negative 1 followed by 5 zeros. Negative 100,000. Number 11, squaring the numerator. Negative 9 squared, that could be done as a mental math step. X cubed, quantity squared, becomes 3 times 2 is 6. Divided by negative 72, x to the 8th. So we have positive 81 divided by negative 72. And we can either subtract the exponents on x or divide and cancel 6 factors of x. That would leave 2 x's multiplied in the denominator, or x squared. If we divide by 9, we get 9 divided by negative 8, x squared. Number 12, the zero exponent rule makes this expression equal to 1. 13, translate a number x decreased by 20. So the variable is x. Decreased by means to subtract 20. 20 less than x. 14, twice the sum of a number x and 8. So twice, 2 times the sum of, so add a number represented by x and 8. Could also distribute the 2 and get 2x plus 16. Number 15. Subtract the polynomials. These are both second degree polynomials. So let's think of distributing the minus in the middle. That'll cause some sign changes because there's a negative 1 that's being multiplied. So in multiplication, negative times a negative is positive, and a negative times a positive will be a negative. So let's drop the first parentheses because the coefficient outside is just a plain positive 1. So we have negative 12x squared minus 400 x, and 2/8 is 1/4, so we could simplify that to 1/4, plus 8x squared plus 1.2x minus 5/6. Combining like terms, the square terms, negative 12 plus 8 is negative 4x squared. Now the linear terms, minus 0.04x plus 1.2, we'll have to subtract 1.20, add a 0 to the far right, and subtract 400. You can think of that as $1.20 minus 4 cents, which would be $1.16, 1.16. Result on positive or plus 1.16x. And the fractions, 1/4 minus 5/6. We have a least common denominator of 12. So 1/4 is 3/12, and 5/6 is minus 10/12. So 3/12 minus 10/12 is minus 7/12. 16, multiply the two binomials with any method, including possibly foiling. So we have a product of first terms, 2x times 3x is 6x squared. Outside terms, outer product is plus 8x. Inside terms, product is minus 15x. And minus 5 times plus 4, the last term's product is minus 20. 6x squared minus 7x minus 20, a second degree trinomial. Number 17 is a binomial times a trinomial. So we cannot FOIL here. We have to use another method. One method is to distribute x times the whole trinomial, x times x squared minus 8x minus 4 in parentheses, and then distribute plus 5 times the whole trinomial, x squared minus 8x minus 4, and distribute x times x squared, x cubed minus 8x squared minus 4 times x plus 5x squared. So we'll write the like terms and above one another in columns, minus 40x and then minus 20. So combining like terms, we have a third degree polynomial result, minus 3x squared minus 44x minus 20. The end. Sometimes we'll use a symbol like small square to say the end. End of the problem.